Ganymede is a wonderful world into its own. It's a moon of Jupiter. It's bigger than the planet Mercury. It's bigger than the Earth's moon, but smaller than the Earth. So it's like a whole planet that's orbiting Jupiter, if you will.
Is it made of rock in the middle with ice on the outside? Is it ice all the way through?
Yeah, that's right. It'll have a rocky core, maybe iron in the core. Ganymede's also interesting because it's the only magnetic moon in the solar system. It has its own magnetic field, just like Earth has its magnetic field. Jupiter has its big magnetic field. And when ions and electrons, charged particles, get trapped on these magnetic field lines, they'll smash on into Ganymede's surface and Ganymede's atmosphere and light up auroral emissions. And yeah, we see an auroral oval on Ganymede, just like we see the northern lights here on Earth. And that's a really neat aspect of it.
That must be stunning. Why did you want to look for water on Ganymede?
Ganymede is an icy satellite. It has lots of water on it to begin with. We think that a couple 100 kilometers below its surface, it has a layer of liquid water. So water is really essential to understanding Ganymede as a world in its overall sense. But we've never really seen evidence for water molecules bouncing around the surface in what we call an exosphere. It's a very tenuous atmosphere, even though we know it was surely there. We just haven't had the telescopic observations to observe it in the past.
And how do you look for water on a rock that's so very far away?
Yeah, it hasn't been easy. There are a couple different ways to diagnose molecules in different atmospheres, and that's the kind of thing that I love to do as an astronomer. In this case, we use the auroral emissions themselves, where we use the spectral fingerprint of hydrogen and oxygen atoms that are coming off of water molecules that are busted apart. So let me walk you through. Okay, so sunlight hits Ganymede's surface, warms it up right at the equator and noon, where those two intersect. We call that the subsolar point. The sun's right above you. And that heats up the surface there. Gases sublimate off the surface, just vaporizing. And don't go into the liquid state, just transition right to gas. And then it's the electrons and ions in Ganymede's magnetosphere and Jupiter's magnetosphere that smash on into that gas, break up that molecule, and make it glow. And so we call that aurora, when a molecule breaks up and glows like that.
And so the colour, the way that it glows tells you that there is water in the atmosphere.
Exactly. The color is very specific. Thanks to quantum mechanics, hydrogen atoms glow at a different wavelength of light than oxygen ones. And when a water molecule breaks up, they have a particular ratio of those brightnesses for those different atoms coming off. And that's what we saw with Hubble.
If anyone finds water somewhere in the solar system other than Earth, the question is, does that mean there might be life on Ganymede?
That's a very good question. That's one of the big objectives for us sending the JUICE mission to orbit Ganymede, to go ask those big questions. Ganymede, yeah, the ocean might be deeper down, but it's still possible that there's life down there. We don't know. If Ganymede's ocean is trapped between ice, liquid ice, then it's harder to imagine how those nutrients would flow into the ocean the same way. But we don't know. We have to go ask that question and go investigate.
And is Ganymede the sort of place where humans might want to inhabit one day?
Ooh, well, I've seen some sci-fi shows where they do have a moon based on Ganymede, and it's a pretty neat idea. But the radiation environment at Jupiter is just so intense. It's worse at Europa, but it's still like you're on the outskirts of a nuclear reactor in terms of you don't really want to live there.